Okie dokie.
So what I'm planning to do today is we're going to do what I was talking about on Monday. And we're going to be working on our polyatomic anions. We're going to be looking for trends in the polyatomic anions. Because again, if you understand the trends, it makes the memory work much easier. And so what I'm doing right now is I do have group 15 in period 3 up, and I do have group 16. Again, I mentioned to you on Monday that group 15 and group 16 are families of 2. So I'm building off of what we described the other day. I'm letting folks catch up on the writing. So let's talk trends. What trends do you notice?
If you go, I guess it's like down from the eyes, they add like a more oxygen.
Okay, so what I call the ATE, whether it's period 3 or period 4, the ATE has 4 oxygens. This is different than what period 2 was. Period 2 was the oddball. But all of the other periods, besides period 2, if it ends in the ATE, it's going to have 4 oxygens. And I should say ends in ATE and there's no prefix. What other things do you notice?
The iodase and height as it goes down, the change of that end of the name.
Okay, they all go from I when we're talking about the element anion to 8 when we're talking about the polyatomic ion that has 4 oxygens to ite when we're talking about the polyatomic ion with 3 oxygens. What else?
In 15,
In group 15, they're all a -3, just like the anion of the element. And in group 16, they will all be a -2, just like the anion of the element. Again, period 2 is an oddball. That's why we're starting with period 3 and period 4 here. But that trend that you see from period 3 and period 4 includes phosphorus, arsenic, sulfur, selenium, and tellurium. The trends you just said, they are good for all of those 5 elements. That means I don't have to memorize everybody. I just need to understand they behave the same. Now I left off again, group 15 and 16 are families of 2. But group 17 is a family of 4. So let's just do, we're going to stay in period 3 here. You have chlorine, chlorine. You have Cl minus, which is chloride. You have a ClO4 minus, which is perchlorate. You have ClO3 minus, which is chlorate. You have ClO2 minus, which is chlorite. And you have ClO minus, which is hypochlorite. What trends do you notice?
The polyatomic ions,
Mm-hmm.
like instead of two of them, there's now four.
That's why it's, instead of two, there's now four. That's why it's called a family of four. And they differ by one oxygen as you go down. What else do you notice? They all have a -1 charge, just like chloride has a -1 charge. So what I have here is I actually have most of this written down, not quite all, but most of it. And on the left-hand side, I give you the trends that we have been talking about. And this is me trying to help you memorize the polyatomics. So if you look at the left-hand side on period 2, when we were dealing with period 2 on Monday, I said the 8 is going to have 3 oxygens. And it's going to decrease by 1 when you go from 8 to 8. Or I'm sorry, and the charge is going to decrease by 1 as you go from boron to down to carbon, down to oxygen or nitrogen. For periods 3 through 7, if you're talking about group 15 and 16, those are families of 2. The 8s all have 4 oxygens. To get from 8 to 8, it's going to change by a single oxygen. Now, for group 17, however, it's a family of 4. And you do change from, each one changes from 1 oxygen. Now, it's not, folks, you've got the non-colored version here, but I do have a version that is in color that is on the website on Blackboard. So, which actually helps a little bit because the problem with this family of 4 is when we're talking about the polyatomic ions or polyatomic anions, the only endings we're allowed is 8 or 8. So we have 8 and 8. You cannot have 2 things that are named identically. So that is why the 4 oxygen gets a prefix of per, so that it can be distinguished between these 2. We have an ite and an ite. Again, you can't have 2 things named the same. So the one with the fewest oxygens gets the prefix hypo. Now, if you look at this sheet, one of the things I'm trying to emphasize is, do I need to remember arsenic, selenium, tellurium, bromine, iodine, aspartame? No. I don't need to memorize any of these as long as I know how these three behave. You know how phosphorus, sulfur, and chlorine behave, then you know how everybody below them behaves too. That's a lot less memory work. Now, in addition to sulfate, you can have this polyatomic ion that is called hydrogen sulfate. In addition to phosphate, you can have hydrogen phosphate. You can have dihydrogen phosphate. Now let's pick all of this apart. Oh, and I should say before we pick it apart, that's also true if we were to do sulfite. You can have hydrogen sulfite. And it would also be true for phosphite. So let's pick these apart. What trends do you notice? Okay, as you add hydrogen, the negative becomes less so. So on sulfate, it was a -2, but on hydrogen sulfate, it's a -1. Now, why is that? Look at where hydrogen is on the periodic table and tell me what you know about that particular group. Group 1 is a +1. So with this, oh, that was interesting. If hydrogen's a +1 and sulfate is a -2, then when we add them together, you get a -1. And that's where that charge comes from. If if hydrogen is a +1 and phosphate is a -3, when you add them together, you get a -2, and that's where that charge comes from. So in other words, you shouldn't have to memorize hydrogen phosphate. You should be able to derive the formula for hydrogen phosphate if you simply know phosphate and the fact that hydrogen's a group 1. What other trend did you notice? The hydrogen, we always put the hydrogen in front. We always put a plus in front. That is actually going to be a useful trend to note when we get to ionic compounds as well. We always put whatever's positive in front. But the other thing we did is we added the word hydrogen when we added a hydrogen. So if you add a hydrogen, you're going to add the word hydrogen. If you add 2 hydrogens, you're going to add the word dihydrogen because the di means 2. So you're literally saying, I have, on this first one, you're literally saying I have 1 hydrogen phosphate. And on the second one, it says I have 2 hydrogens and a phosphate.
Can you like add hydrogen to like
Exactly. Now that's, you can add hydrogen to anything that already has, that has a -2 or a -3 charge. And you would just add the word hydrogen to the name. That doesn't quite work for our -1 charges because they make neutral compounds, but it does work for everybody else. Okay, so I have just about run out of all of the tips and tricks I can give you. And again, most of them I have outlined on this sheet of paper. Because to be quite honest, I am not, now, yes, I have them all memorized. But I needed those tips and tricks and trends when I was learning them because I became very overwhelmed very quickly. So you do have a copy of this again on Blackboard if you were to lose your copy. In addition, you have a copy of this document, which has all of the ions, most of the metal ions, and many of the the polyatomics, which we've got a few to still go over. But if you follow these trends, it'll help you it'll cut down your memory work quite a bit. And to be quite honest, nobody ever told me how they matched up on the periodic table. I just happened to be listing things out one day. And I realized that the charges were always the same for period 3 and period 4 and period 5 as it was for the element. Nobody ever told me that, or my life would have been easier. So that's just, I'm trying to give you some of these things I've found over the years. The other thing that's on Blackboard is a Quizlet. So I know you won't, that way if you don't want to make your own flashcards, you got a Quizlet you can pick up and use on your phone anytime. And that way you can quiz yourself over the polyatomics because you have to have them memorized. You have 2 weeks before your, I think it's October 6th is your next exam and you got to have them memorized. So that's a little over, it's a little over 2 weeks. Now, there are some that I just could not help you memorize. You're just stuck memorizing them. And unfortunately, some of the important ones are in that grouping. So for instance, one that we will use a lot in chemistry, it has a variety of ways it can be written. You'll see it written in this format, or it may be written in this format, but they mean the same thing. And this is the polyatomic ion acetate. Although I do not want to play with it, I do use it in things, and this is cyanide. So yes, if you have ever thought of cyanide poisoning, this is the polyatomic ion that's in it. When you go to the grocery store or to Walmart or to some Walgreens or CVS and you pick up that brown bottle of peroxide, this is the anion, this is the polyatomic ion that's in it. Another important one is OH minus, which is hydroxide. In the laboratory, we tend to use bases, and most of the bases we use have a hydroxide group. So you will see it quite a bit. Now I've given you other ones on here, but these are the 4 that if I had to memorize, I'm double checking my list here. If I had to memorize 4 that did not fit the trend, these would be the 4. All the rest of them that I expect to use in this class will fit the trend, the trends that I've given you. So let's just start practicing. And I'm gonna mix them all up. And I will say the first question I ask myself is it a cation or is it an anion? Because you have rules for your cations and you have different rules for anions. Questions about the answers on the board? Yes.
Um, I think carbonate, why is it carbonate and not like?
Okay, so carboxylate is something else. Carboxylate is a different substance than carbonate.
The peroxide, is that like?
Peroxide is a thing. Carbide is a thing, but not carboxide per se. There actually is something called carboxylate, but so your second question.
Chromium has like a 3 for the 3 plus, but why doesn't it?
Because aluminum is one of the ones whose charge is always the same. And so you just name the metal and name the ion, put the word ion. Other questions? Hydronium. So there were two cations that were polyatomics, and that just happens to be one of them. And it's one you have to memorize. So same thing with ammonium. It just happens to be one of the ones you just have to know. That's a cation. It's called hydronium though because of the way it's mixed with, if I were to take this apart, the reason it's called hydronium is you have hydrogen mixed with water. And so that's how it comes to be. Next question. Okay, I'm going to give you a chance to work on your memory work. Again, you've been forewarned that you've got a little over 2 weeks and you got to know them. know your polyatomics. There is, if you prefer a list, there is a list. It's 2 pages. Now, part of this list is a lot of the metal ions, the more common metal ions. It doesn't even include all of them. That would be hard. But it does include a lot of the common ones. And then it includes your anions, and it includes your polyatomic ions. So it's a pretty thorough list. You've got the Quizlet I put out has 107 cards in it. So it's a pretty thorough list. Memorizing your trends will help in minimizing the amount of memory work and better understanding what's going on. Now you have a lot of work ahead of you. And if you'll get started on it, you may be able to win some bingo, because we're going to play polyatomic bingo on Friday for some candy. So, and I've got dark chocolate, milk chocolate. I've got Reese cups. I've got Crunch bars. I've got Kit Kats. So I've got a variety of things to play. And it's all about helping you memorize them. So any questions for me? We're getting out early again, because that's what we're up to, is just memorizing.